Welcome back to the Cyber Lab. So glad to have you here for today's explainer. Look around. We're constantly surrounded by these flowing, dynamic streams of digital code. But have you ever actually stopped to wonder how security pros see the underlying structure of all this? How they map the invisible? Well, today we're diving into Nmap. It's an open source engine, and honestly, its raw packet control has made it the absolute bedrock of network reconnaissance for over 25 years now. Whether you're validating a massive firewall migration or just hunting down rogue services, Nmap is your ultimate lens for network visibility. Looking at our neon green mission readout here, we've got a tight agenda. We're going to cover the mapping engine itself, host discovery and ping sweeps, the actual art of port scanning, decoding those tricky port states, and finally we'll unleash the Nmap scripting engine. All right, section 1, the network mapping engine, seeing the unseen. Let's talk about how Nmap takes the absolute chaos of network infrastructure and brings some much needed order to it. It really begs the question, doesn't it? How exactly do you map the invisible borders of a digital network? I mean, infrastructure is constantly shifting, yet visibility gaps are still, by far, the single biggest enabler of successful intrusions. It's simple. If you don't know what's literally on your network, you can't protect it. Nmap solves this, and it does it by adapting to your specific intent without hiding all its mechanics behind those annoying, opaque abstractions. It gives you raw, unfiltered control. Moving on to section 2, host discovery and ping sweeps. Finding the active targets. It's time to reduce that massive, overwhelming sea of IP addresses into a concentrated, actionable list. Think of discovering hosts as finding the actual physical houses on a digital street. It is the critical first step. Take a network like a standard 10.0.0.0/8. That space has over 16 million IP addresses. But in reality, it might only be used by a company with, maybe 1,000 machines? Scanning every single port on 16 million IPs? Yeah, that would take literally forever. So Nmap uses a clever mix of default probes, things like ICMP echoes, which are basically your standard pings, along with TCP SYN and AK packets. Why? To sneak past strict firewalls and force a response. For instance, you can use the -SN command for a quick ping sweep. It just counts the available machines without setting off any alarms. Or you've got -SL, the list scan. That's essentially a sanity check to make sure you're targeting the right organization by resolving host names, all without sending a single packet to the target itself. Oh, and if you already know a firewall is eating your pings, just use -PN. That tells Nmap to skip discovery entirely and just force a scan on all the IPs you gave it. Which brings us to section 3, the art of port scanning, checking the doors and windows. Once we know the houses are actually there, we need to check which ones are open for business. This right here perfectly illustrates the absolute go-to default scan option, the TCP SYN Scan. You'll also hear it called a stealth or half-open scan. When you run Nmap with raw packet privileges, it doesn't bother opening a full, noisy, heavily logged TCP connection. Nope. Instead, step 1, it fires off a SYN packet, acting like it wants to connect. Step 2, if that port is listening, the target eagerly fires back a SYN ACK. But then, and here is the absolute genius of it, step 3 happens. Nmap immediately slams the door by sending an RST or reset packet, tearing the connection down before it's even officially established. Boom! You get the answer you need without ever completing that 3-way handshake. It's incredibly fast, and crucially, it's relatively unobtrusive. But what happens when we lose that nice, reliable TCP handshake? Let's contrast that with UDP scanning. UDP is connectionless. No handshakes, no pleasantries. If a UDP port is open, the service often just swallows your empty Nmap probe and gives you absolutely nothing back in return. Total silence. If it's closed, okay, it might send an ICMP port unreachable error, but here's the catch. Systems heavily rate limit those error messages to prevent themselves from being overloaded. Because of that, UDP scanning can be agonizingly, painfully slow. To put that into perspective, in one of our source examples, scanning just 1,000 UDP ports on a basic Linux machine took almost 17 minutes. Just for 1,000 ports. So that silence leads us right into section 4, decoding Nmap port states, interpreting the locks. Because the whole game is understanding what the network's responses, or lack thereof, are actually trying to tell us. Let's pull up this slick holographic UI box and run through the primary states Nmap spits on. When a port is open, pretty simple, an application is actively accepting connections. Closed means the port is totally accessible, but there's no actual application listening on the other side. Then we have filtered. This one is the frustrating one. It means a firewall or a router is outright dropping your probes, so Nmap has literally no idea if the port is open or closed. Finally, unfiltered. You'll typically only see this pop up during an ACK scan. It basically means, hey, the port is reachable, but Nmap still can't quite determine its open or closed status. Now, I really want to hammer home this vital distinction between closed and filtered ports. You know, novices often look at a closed port and think, dead end. Actually, scratch that. A closed port is incredibly valuable intel. It confirms for a fact that the host exists and is reachable on the network. A filtered port, on the other hand, that means we've just bumped into a security guard. A firewall is actively in play, it's dropping your packets into a black hole, and it reveals absolutely nothing about whether some juicy, vulnerable service is hiding behind it. And naturally, that brings us to the headache of ambiguous states, specifically open pipe filtered. Remember a minute ago when we talked about UDP ports often giving zero response? Well, certain TCP scans like FIN or null scans also get the exact same silent treatment from an open port. So when Nmap sends a probe and gets nothing but crickets back, it's forced to play a guessing game. Is the door actually wide open and the service just isn't saying hello? Or did a firewall just silently eat the packet? Without a definitive response, Nmap just shrugs and classifies it as open/filtered. All right, let's escalate to the heavy artillery of this mission. Section 5, the Nmap scripting engine. Automating the reconnaissance. Checking out this intercepted cheat sheet glowing in front of us, you can see the actual real-world commands used for aggressive network probing. Look at the syntax here. You're using that -- script flag, followed by broader categories like vuln, or even highly specific scripts like SMB-OS discovery. We're not just looking for open ports anymore, folks. This is about actively, aggressively interrogating the services running on those ports. The Nmap scripting engine, or NSE, literally transforms Nmap from a simple door checker into this automated vulnerability hunting Swiss Army knife. It's written in the embedded Lua programming language, which means anyone can write and share custom scripts. It handles advanced network discovery like ripping SNMP device data or pulling Whois domain records. It also does incredibly sophisticated version detection. For example, identifying the Skype version 2 service actually requires 2 completely independent probes. Standard Nmap can't do it. NSE handles it effortlessly. And for vulnerability detection, it's an absolute powerhouse. Get this, when the massive Heartbleed bug hit, Nmap developers pushed out a detection script in just 2 days. It can even sniff out complex backdoors left behind by attackers, like the infamous double pulsar. But that brings us to a pretty intense reality. To quote the official documentation directly here, as a general scripting language, NSE can even be used to exploit vulnerabilities rather than just find them. We really have to impartially recognize that while this is an absolutely critical tool used every single day by security pros and pen testers to lock things down, it is the exact same engine used by threat actors to automate their breaches. The flexibility of Lua scripting means that if a vulnerability can be mapped, there's a good chance it can be exploited right from within Nmap itself. And because of that immense power, we absolutely must talk about the golden rule of scanning. Listen closely. Only scan networks and systems that you personally own or that you have explicit written authorization to test. No exceptions. Unauthorized port scanning, especially once you start firing off those intrusive NSE scripts, can crash legacy services, trigger intrusion detection alarms, and ultimately violate computer crime laws in your jurisdiction. Knowledge is a superpower, but it has to be applied legally and ethically by all of you out there learning this stuff. So, as we wrap up today's explainer, I want to leave you with a final, provocative thought. With a tool like Nmap, the invisible borders of literally any digital network can be mapped out in neon green. You can find the active hosts, you can check all the doors and windows, and you can even deploy automated scripts to test the strength of the locks. But here's the thing. The race between defense and reconnaissance, it never actually stops. You can map the network and find the open doors, but can you secure them before someone else does? Thanks for dropping by the Cyber Lab today. Keep exploring, keep questioning, and above all, stay secure.